All right, okay, guys, let's start. Okay, so yeah, please work on last reaction. Okay, so on the screen. Okay, on the document camera. Okay, so this one just somehow kind of practice. Yeah, we left in the lecture on Friday, last Friday. Okay. All right. So when you are working on this question, okay, a couple of things, okay. So first, this week's kind of NMR IR the week, okay, and but there's kind of problem with the IR, okay. So maybe the lamps burn out, okay. So in this case, this week we only run NMR, okay, carbon NMR, okay, and make sure you review how do you run the carbon NMR, okay. So no IR, no IR, okay. So actually IR cannot provide too much information about dependent chloride, okay. So that's just nothing, okay. And so nothing due this week, okay. So no pre-lab, no post-lab, okay. So but just make sure you bring your goggles and those wear face mask when you come into the lab, okay. And so let's see what else, okay. Yeah, if you don't feel well, okay, so you feel sick, whatever, okay, so don't come to the lab, okay. So I can scan carbon NMR and then send to you, okay. Just send me email, okay. So so actually kind of not too much work for this week, okay. But if you feel good, okay, please still come in, okay. So make sure you sign up the IR NMR time slot, okay. And so just one reminder, okay, so chapter 9 homework is due tonight, okay, so make sure you finish your chapter homework, chapter 9 homework, okay. And I'm still going through kind of the quiz 2, okay, so quite a bit today and also tomorrow, okay, so probably I finish go through the quiz 2 on Friday, okay, so give you guys kind of back some kind of partial credits, okay. And if you probably in the discussion tomorrow, I will kind of go through kind of quiz 2 also, okay. All right, okay, so we continue continue the lecture, okay. Okay, so if you have any question, okay, please just type in the chat window, okay. Right, so last time we learned kind of the ring opening of the epoxide, okay, epoxide kind of 3-member ring, okay, so 3-member kind of ether, okay. And so either on the acid condition or on the basic condition. On the acid condition, kind of the stereochemistry full SN2, but the regiochemistry full SN1, okay, attack on the last substitute carbon, okay. If you kind of under the basic condition, okay, so stereochemistry, regiochemistry both full SN2, okay, so attack kind of electric kind of acid condition, attack kind of more substitute carbon, and then basic condition attack on the last substitute carbon, okay, so that's the acid condition, regiochemistry follow kind of the SN1, okay, and then stereochemistry follow SN2, okay. So basic condition both kind of SN2, okay. All right, so that's here, okay. So this epoxide, okay. All right, and then we do the kind of basic condition first, okay. So find kind of the 2 carbons, okay. So either attack here, back attack, or either back attack here, okay. And so because the sodium azide, okay, that's somehow kind of neutral or even kind of little bit the basic, okay. So in this case here, the azide will attack, back attack last substitute carbon, okay. Somehow kind of like SN2 reactions, okay. Right, and then after reaction, okay, so you have to show the stereochemistry, okay. Right, so open ring like this way, okay, and then okay, so for the right carbon, everything keeps same, okay. For the left carbon, okay, so pretty much also everything keeps same, okay. So and 3, okay. So that's the kind of N3 kind of nucleophilic kind of the ring opening of epoxide, okay. Right, for the right ones, kind of the acid condition, okay. So real nucleophile kind of water can actually kind of eventually give kind of the OH at the nucleophile, okay. Right. Okay, so for this reaction, normally there's kind of one actual work up step, okay. So so normally you get kind of the water, okay, to work up, okay. So there's kind of 2-step reaction, okay. And but just to avoid kind of confusing for you guys, okay. So I just kind of show the major reaction, okay. Right, okay. So for the acid conditions, okay. So the water actually kind of attack here from kind of the right carbon, okay, open ring like this way, okay. Right, in this case here, the real product should like this. Right, so OH actually kind of on the right carbon, okay, and then give you kind of this kind of stereochemistry, okay. So both back talk about kind of just see kind of difference in kind of the open ring, okay. Right. Make sure you understand that, okay. So that's kind of the one of the most difficult part for the chapter 9, okay, chapter 10, okay. All right, so we continue, okay. If you have any question, go ahead, type in the chat window, okay. Right, so now we move to the next kind of the nucleophilic reaction, okay. How do we make the ester, okay? So let's go here and then on the slides. Right. So the fourth one, okay, so how do we prepare the ester, okay? Right, so ester, hopefully you guys still remember the hopefully you guys still remember its structure, okay? So that's R, okay, and then carbonyl O and then R prime, okay? So that's ester, okay? And for the ester preparation, by kind of the SN2 reaction, actually kind of we already learned in the alcohol preparation, okay? So in the secondary kind of alcohol, okay? And then the real nucleophile actually kind of this guy, okay? So that's what we call kind of carboxylate, okay? Okay, so that's real nucleophile. The real nucleophile actually is this oxygen, okay? So that's make sure that you draw kind of right bond formation positions, okay? Right, and here I draw you kind of what's the general reaction for this reaction. Actually, kind of also show there, okay. So you have kind of the carboxylate kind of nucleophile, okay. So the carboxylate you can also draw like this way, okay. And then react with kind of substrate, okay. So with the link group, okay. All right, and then after reaction, okay. So the oxygen build bond, okay, with kind of the R, okay. That's something to keep in mind, okay. And then you get some kind of link group, okay. So for the carboxylate case, so nucleophile case, so that's we learned in the chapter 9 case, so that's the moderate kind of the medium kind of nuclear but weak base, okay. So that's perfect for the SN2, okay. So in this case, if you prepare some kind of any you use kind of any kind of secondary or primary kind of substrate, okay, no problem, okay. So primary or secondary case. So one give kind of the E2 reaction product, okay. All right, and then I give you guys kind of the two example, okay. So right, so this one we react with kind of the benzyl bromide. So for the this reaction, okay, so normally speaking, student can draw the right product. Just one thing to keep in mind, okay, so where's bond formation, okay, you form a kind of bond between this carbon and this oxygen, okay, so that you have to kind of draw the right way, okay. Quite often happen kind of student kind of just put directly the whole methyl group on here. That's wrong, okay. Yeah. And another one, okay, so this time we use kind of the benzolate kind of the benzoic acid kind of the R9 as nucleophile, okay, and react with some kind of secondary kind of the substrate, okay, right. So this is a real nucleophile, okay. Don't be fooled by some kind of the metal counterion, okay. Right. So that's when you replace the link group, okay. So All right, keep in mind, okay, so oxygen, that's the real kind of the nucleophile, okay, and then the whole part, okay, so we do like this. And then plus the sodium bromide, okay, so that's actually you don't need to show it, okay, but if you show it, that's fine, okay. All right, and that's pretty straightforward, okay, easy, okay, reaction, okay. All right, so that's the ester preparation, okay. So now we move to another one, okay. So alkyl halide preparation. So alkyl halide case, so that's one of the most the useful the organic compound. Okay, you can use alkyl halide kind of the as the substrate okay prepare any other compound. Okay, so here kind of the opposite rule. Okay, so we want to prepare the alkyl halide. Okay, so normally speaking, kind of we prepare alkyl halide from kind of alcohol. Okay, so we will learn actually we already learned several ways kind of prepare the alkyl halide from alcohol. Okay. And the first way is kind of just before we talk about kind of the alkyl halide preparation, okay, just keep in mind, okay. So if you want to convert the alcohol to alkyl halide, okay, so we have the convert OH group to some kind of Goodling group, okay. Right. And then you do some kind of the substitution reaction, okay, and then get kind of the alkyl halide, okay. So that's you cannot directly kind of the convert to kind of alkyl halide, okay, convert to Goodling group, okay. Right, and then the first way actually we already learned kind of just use the acid HX, okay. Right, HX, okay, so that's the general reaction showed here, okay. So pretty much you have kind of alcohol, okay. Right, and react with the HX, okay. So the hydrogen, okay, try to pronate kind of OH group, okay, and then convert OH group kind of the betaline group water, okay, and then X coming, okay, remove now water, okay, and get kind of a final product, okay. All right, and then when we come kind of the more detailed kind of what kind of alkyl halide, okay, so that's a little bit difference, okay. So if you want to convert kind of alcohol to iodide, okay, so you can use kind of the HI, okay, so that's no problem, okay. So HI is kind of a very strong base, okay, so can do the reaction, okay. And but if you want to convert kind of to bromide, okay, so that's the hydrogen bromide, okay, so also pretty good, okay. So both very strong base, okay, strong acid, okay. But if you want to prepare kind of the chloride, okay, so HI is kind of not enough, okay. HI is HCl is not enough, okay. So you have to add zinc chloride, okay, plus HCl, okay. This guy. The reason for that kind of HCl is kind of we know that kind of strong acid, okay, but not as strong as kind of HI and also HBr, okay. So we need add some kind of Lewis acid, okay, zinc chloride, okay. So that's kind of make the OH kind of better, okay, and then you can do substitution reaction, okay. So that's the little bit keep in mind, okay. All right. And so that's one thing you need to keep in mind, okay. And then second thing, okay, so if you prepare kind of you convert primary alcohol to primary alkyl halide, okay. So that's let's do this, okay. Okay, so primary alcohol, okay, actually kind of follow the SN2 reaction, okay. But if it's kind of the secondary alcohol or tertiary alcohol, okay, that's actually kind of flow SN1 reaction, okay. Right, so the SN1 reaction problem kind of we already talked about many times, okay. So the first kind of lowest steric chemistry, okay. So you get kind of both R and S, okay, racemized, okay. And then second kind of here the E1 elimination will compete, okay. And then third problem kind of rearrangement, okay. So yeah, because your S1 you just kind of carbon cation, okay. So that's the but the unfortunately, so yeah, if you have to use the secondary tertiary carbon alcohol, okay, so you have to kind of get some kind of this kind of problem, okay. Right, example, okay, so remember, okay, so this week's lab, actually kind of also last week, okay, we try to convert kind of T-pentyl alcohol, okay, into kind of T-pentyl chloride, okay. Yeah. And very strong acid, okay, so that's pretty straightforward, okay. So yeah, this time we did use kind of zinc chloride, okay. Zinc chloride, okay, normally use for kind of primary alcohol, okay. Right, and then in the handout, okay, so yeah, I also tell you guys, okay, generally kind of the alkene byproduct, okay. Reason for that, okay, so this is kind of the S1 reactions, okay, you generally kind of also E1 product, okay. So that's just kind of combine some kind of this week lab, okay. All right, some questions. Okay, so zinc chloride here can act as the acid, okay. So actually kind of the Lewis acid, okay. So yeah, make the OH group kind of better than group, okay. So yeah, has nothing to do with kind of the nucleophile or kind of the other kind of region, okay. So yeah, just kind of you just treat that kind of very strong acid, okay, very strong acid, okay. So that's first way, okay. And then the second way, kind of actually we also learned it, okay. So we do two-step reactions, okay. Convert OH group kind of to mesylate and tosylate and also triflate, okay. And then do the substitution reaction, okay. So this one kind of still draw for you guys, okay. So yeah, we use kind of methyl chloride, okay. All kind of total chloride, all kind of the triflate chloride, okay. Right. So normally under the little bit kind of the basic condition, okay. Right. So that's convert kind of OH good kind of to the tosylate, okay, or kind of the mesylate, or kind of triflate, okay. And then following you can go ahead to kind of the substitution reactions, okay. So come in, okay, and then just kick off the link group, okay, and you get kind of the alkyl halide, okay. And so here I just kind of show you guys, okay, so that's one way we draw kind of multiple step reaction, okay, just kind of one arrow, okay, and then show kind of intermediate, and then draw kind of another arrow can show the kind of reaction condition and the product, okay. So but sometimes kind of if you want to save some kind of time, okay, so yeah, for the two-step reaction, okay, you can draw like this way, okay, so yeah, some starting material, okay, and then so above the arrow, you draw the reaction region and those conditions for the first step reaction, okay, and then below the arrow, you draw this kind of the region and also the region and also the conditions, okay, for second step, okay, and then that's eventually you draw kind of product, okay. So that's another way showed kind of multiple step reactions, okay. All right, and then this one, okay, so yeah, should be one example, no, okay. So just quickly show you guys one kind of example, okay. Right. So we have this alcohol and then use the total chloride, okay, and then with pyridine, okay. Right. Convert OH group to kind of the tosylate, okay, and then folding, okay. So you can use kind of sodium iodide, okay. So directly replace kind of the OTS, okay, and then get kind of final iodide product, okay. Pretty straight reaction, okay, and then but the only problem kind of you have to do two steps, okay. So a little bit boring, okay. Sometimes kind of sometimes okay, okay. So you don't need even isolate kind of the intermediate. Sometimes you have to isolate, okay. So all right. So is any easier way to do this reaction? Answer is yes, okay. So that's we come kind of the third way to prepare kind of the alkyl halide, okay. Right. And we use some kind of magic reagent, okay. Right, and then first one is how do we prepare kind of the alkyl chloride, okay? So we use kind of thionyl chloride, okay. SO, okay, oxygen and then chloride, okay. So this one we call kind of thionyl chloride, okay. Right, very pretty good reagent, okay. And then if you react it with kind of any alcohol, okay, actually not any alcohol, okay, secondary and primary alcohol, okay, and then just one step, okay, you convert it to kind of chloride, okay. Right. Pretty beautiful reaction, okay, and the reason for that kind of the very high yield, okay, and also mild conditions, okay, and the most important kind of the two byproducts, okay. So one kind of the sulfur dioxide, another kind of HCl, okay, and all just kind of become kind of gas, okay, and then when you do kind of roadmap, whatever, okay, so kind of gone, okay, so whatever left over, that's kind of your pure product, okay, yeah, right. So for this reaction, okay, so we are actually similar like totally and also mesylate, okay, so you convert an OH group to kind of beta group, okay, and then chloride coming kind of do replacement, okay. So the mechanism not required, okay, but I can quickly draw for you guys, okay. Yeah, just keep in mind this mechanism not required, okay. But you can little bit get idea, okay. So this is thionyl chloride, okay. So pretty much the OH attach kind of the sulfur kick off the one of your Cl, okay, something like this. Right, and then some base or maybe some kind of another chloride, okay, pick up this the Cl, okay. Give you back kind of like this, okay. So this is kind of the very good link group, very good link group, okay. And then the another Cl coming, okay. Coming here, okay. Attack, and then this one go here, and then this one pick up some kind of hydrogens, okay. So the hydrogen actually kind of left from here, okay. Right. And then eventually you generate kind of the RCl, okay, and the plus kind of sulfur dioxide. So this part leave as sulfur dioxide, and then HCl leave as kind of HCl, okay. Pretty nice and beautiful reaction, okay. I did this reaction many times, okay. So each time even don't need to purify it, okay. So after reaction done, okay. So you use kind of excess of kind of thionyl chloride, okay. So this one actually also volatile, okay. And so just you do it kind of after reaction you kind of just do road fab, okay. Easily remove this one and also any side product. Only kind of get kind of chloride after, okay, back, okay. So just very nice reactions, okay. And just only problem kind of this thionyl chloride a little bit toxic, okay. Please do this reaction in the hood, okay. So and also in future, okay. So whenever you see thionyl chloride, okay, SOCl2, you should get kind of quite excited, okay. Reason for that kind of for all the organic chemistry reaction we learn in organic chemistry 2, okay. So the only route for the thionyl chloride can convert OH to Cl, okay. OH to Cl, okay. So whenever you see thionyl chloride, first thing you need to look at kind of where's OH, okay. So easy just convert kind of OH to Cl. That's it, okay. So that's the reaction, okay. Right. And then next kind of we also have some ways to convert kind of OH to kind of the bromide and also the alkyl bromide and also alkyl iodide, okay. But we have to use some special reagent, okay. For alkyl bromide, we use kind of the PBr3, okay. So this one called kind of tribromophosphin, okay. So but most people just call kind of PBr3, okay. And another byproduct kind of OPBr2, okay. So this reaction actually kind of pretty also high yield, okay. So this is kind of precipitation out, okay. So after you done reaction, after you do the filtration, okay. So get kind of only product in the solution, okay. And similar thing for the kind of alkyl iodide, okay. So you use Pi3, okay. so called kind of yeah, triiodophosphine cane. Yeah. So pretty efficient reactions, okay. And in future, if possible, okay, try to use this third way, okay, to prepare chloride, bromide, iodide, okay. So but just keep in mind, each of them you need kind of a very special reagent, okay. So that's some kind of new way we learned kind of how do we prepare kind of the chloride, bromide, iodide, okay. And then the first three, okay, so all based on kind of alcohol, okay. Actually, kind of you can also do kind of halide exchange, okay, and to prepare the alkyl iodide from kind of alkyl chloride and also alkyl bromide, okay. So this one kind of only can be used kind of prepare kind of the alkyl iodide, okay. So cannot be used to prepare kind of the alkyl bromide and also alkyl kind of the chloride, okay. And so reaction actually. Okay, so yeah. By the way, okay, so for this, okay, so you can use kind of the primary alcohol or secondary alcohol, okay, for the all these three, okay, so very mild reaction condition, no tertiary, okay, right. Okay, so last one kind of we call the halide exchange, okay. So for this one, okay, so show you guys what's going on, okay. So you have kind of the alkyl chloride or alkyl bromide, okay. So maybe use kind of color pen, okay, show kind of link group, okay. Right. And then we use some kind of special reagent, okay. So the sodium iodide, okay, in acetone, okay. Right. And once reaction is done, okay, and then you get kind of the iodide, okay, alkyl iodide, okay, and then plus the sodium the chloride or sodium bromide, okay. Right. So why this reaction working, okay? So reason for that kind of the sodium iodide, okay, can be dissolved in the acetone, okay. So you can see kind of the sodium here is an acetone, okay. And then once reaction is done, okay, so just kind of sodium chloride and also sodium bromide, okay, both cannot dissolve in the acetone, okay, will precipitate out, okay. Okay, and then that can push equilibrium to the right, okay, and give you kind of iodide, okay. So you cannot do the reverse way, okay. So so the limitation for this reaction, okay, only for alkyl iodide, okay, alkyl iodide, okay. So but this reaction kind of pretty efficient and also pretty cheap, okay. So sometimes kind of people use it a lot for the prepare iodide, okay. So and actually kind of pretty also efficient reactions, okay. And give you guys one example, okay. So we have this bromide, okay. So keep in mind, okay. So for this reaction, okay. So pretty much still follow some questions. Back with no. Yeah. So that's reaction stop here, okay. So this is kind of the dead end, okay. So this you cannot do kind of second or third kind of the replace it kind of the alcohol, okay. So this reaction here, okay. So All right, okay, continue, okay. So we have this bromide, okay, and then we react with kind of sodium iodide, okay, and then acetone, okay. Right, so once your reaction is done, okay, so keep in mind, okay, so that's the SN2 reaction, okay, so you get kind of the iodide, okay. So white line become dash line, okay. And then normally speaking, you don't need to draw kind of the inorganic compound, okay. But if you want to draw it, okay, so that's sodium bromide kind of precipitate out, okay. All right. So that's the all about kind of alkyl halide, okay. So first three based on the kind of the alcohol case. So yeah, we convert alcohol to kind of active halide case. So yeah, either one step or two step case. So yeah, the recommended kind of you guys use kind of the third way case. So yeah, the thionyl chloride for the chloride case, PBr3 for BRK, and then PI3 for the iodide case. And then last one case, so only halide change convert one halide to another halide case. So not so efficient case, but the sometimes kind of if you prepare kind of the active iodide should be it's fine. Is the change of theory because that's right, okay. Yeah, this is SN2 reaction, okay. Right. So remember, okay, so that's the secondary substrate, okay, and this kind of good nucleophile weak base secondary, good nucleophile weak base SN2 reactions, okay. Yeah. So that also means here this reaction only work for kind of primary and also secondary substrate case. So cannot use for tertiary one case. So tertiary, it's very hard case. So pretty much no reaction case. All right, and then we move to another one case. So amine case. So that should be 5. What's going on? 4, 5, or 5 should be kind of alkyl halide case. So 6 should be kind of amine case. Right. So here we use the substitution reaction, prepare all kinds of amine. Okay. So before we learn that case, so we have to little bit I want to little bit refresh you guys' memory about kind of your classification of amine. Okay. So yeah, this one is kind of ammonium. Okay. So no alkyl group, it's 3 hydrogens. Okay. Right. And then primary amine. Okay. So yeah. 1 alkyl group, 2 hydrogens, okay, so that's here, primary K. And then secondary amine K, so yeah, 2 alkyl group K, and then 1 hydrogen K, so that's here, secondary K. And then tertiary amine K. 3 alkyl group K, no hydrogen K. So there's a kind of additional one K, quaternary amine K. So quaternary amine is something like this K. The quaternary amine actually kind of the cation K. So yeah. So sometimes people call it kind of the ammonium K. Ammonium K. That's right. Okay. So yeah, quaternary amine K. Right. Okay. So now we start kind of learn how do we do kind of the amine formation K by SN2 or SN1 reactions. Okay. And the first case, so amine itself actually kind of a good nucleophile K, and easy for SN1 SN2 reactions K. But the only problem kind of if you directly do kind of the SN2 reactions, okay, so maybe get messed up, okay. So that's also showed here, okay. Okay, direct acylation. That's the first way to prepare the amine, okay. And this one, okay, so keep in mind, okay, only okay. You prepare kind of the tertiary amine, okay, from the secondary amine, oh yeah, prepare kind of the quaternary amine from the tertiary amine, so only these two, you cannot use to kind of prepare primary amine and also secondary amine, so only can be used to kind of prepare kind of tertiary amine, quaternary amine, only these two. Okay, yeah, these two K, tertiary and then quaternary K. All right, so first, that's actually kind of the general reaction already showed you guys. Okay, there. Okay, so yeah, okay, so maybe let's still write it here. Okay. All right, so we prepare kind of the tertiary amine K. So that's we start with kind of secondary amine K, and then we react with some kind of the alkyl halide whatever K. Good in group K. Right after reactions, okay. So you just somehow like exchange, okay. So pretty much you need do a little bit of work up to remove this hydrogen, okay, and then you just kind of tertiary amine, okay. And the link group case kind of pick up by some hydrogen, whatever, okay. So that's your tertiary amine. Okay. And similar thing, okay, so if you want to prepare quaternary amine, okay, quaternary amine, okay, so we start with kind of the tertiary amine, okay. Right. Start with tertiary amine, and then again with some kind of alkyl halide, okay, whatever, okay. So this time just kind of put one extra kind of the alkyl group onto the tertiary amine, okay, and then generate kind of quaternary amine, okay. Doesn't matter, okay, so 3. Yeah, quaternary amine, keep in mind, okay, so that should be a positive charge on it, okay. So why we cannot use this reaction directly prepare the primary amine or secondary amine, okay? So reason for that kind of is you get over reactions, okay? All right, give you guys just one small example, okay? So for example, right. So we start with kind of ammonium, okay, and react with the ammonium, okay, react with some kind of alkyl halide, okay. So even you put these two in 1-to-1 ratio, okay, and then you try to this is kind of pretty good nucleophile. You try to just kind of get kind of primary amine, okay. But for the reality case, you get kind of mixture, okay. Not only this primary amine, you get kind of the secondary amine, okay, and the tertiary amine, and even quaternary amine, okay. Even you get kind of the 1-to-1 ratio, you still get kind of this mixture, okay. Right. So why is that? Okay, because primary, secondary, tertiary amine, okay, so and quaternary amine, they have kind of different nuclear facility, okay. So nucleophile, okay, strength of nucleophile, okay. Right. Nuclear facility, okay, so in this kind of order, okay. So weakest one kind of the ammonia, okay, followed by kind of primary amine, okay, and then followed by kind of the tertiary amine, secondary amine, okay. And then secondary amine actually has a similar the nuclear facility as kind of the tertiary amine, okay. Yeah, so primary, secondary, tertiary, okay. So if you generate kind of primary amine, okay, so just for example this one reaction, okay, generate, and that's the better nucleophile than the ammonium, okay, and then quickly kind of do the second accumulation, okay, put second amine, okay, and then go ahead maybe generate tertiary or kind of quaternary amine, okay. So you cannot stop at this stage, okay. And so because that's kind of better nucleophile, this one also even better nucleophile, okay. Why is in this order, okay? Because the RQ group, okay, somehow kind of electron donating group, okay, donate electron into the center nitrogens, okay. So if you have one RQ group donate kind of into nitrogen, make nitrogen some kind of the more electron rich, okay, more electron rich, better nucleophile, okay. So primary amine has one RQ group, okay, and the secondary amine has 2 RQ group, okay, make kind of nitrogen even more kind of rich with electrons, okay, and then better nucleophile, okay. So speaking, kind of the tertiary amine has kind of better nuclear facility because it has kind of 3 active donate electron into center nitrogen, but because kind of steric hindrance, okay. So in this case, tertiary amine has a similar kind of the nuclear facility as kind of secondary amine, okay. So that's in this order, okay. And for you guys, just remember, okay, so you'll never use kind of the direct accumulation prepare kind of primary amine, secondary amine, okay, because you get kind of mass up, you get all the kind of possible product, okay. Yeah. So even you kind of just 1-to-1 ratio of the region, okay. Yeah, electron donating group, okay, EDJ, okay, electron donating group, okay. Yeah. All right. So multiple accumulation, okay. So that's something keep in mind, okay. Only for the kind of the tertiary and also quaternary, okay, because if you use kind of secondary amine, okay, prepare kind of tertiary one, okay. So yeah, tertiary one not as strong as kind of, yeah, pretty much similar kind of as kind of secondary amine, okay. One kind of gets kind of, yeah, more accumulated, okay. And similar thing here, okay. So yeah, prepare kind of, yeah, quaternary amine from, yeah, the tertiary amine, okay. So that's, yeah, the one kind of get kind of, yeah, the, yeah, overreaction, okay. Right, so here comes question, okay. So if you really want to prepare kind of primary amine, okay, how do we do, okay? So we'll learn two reactions, okay? So yeah, prepare, yeah, the primary in, we call kind of indirect way, okay? First one we call kind of, yeah, Gabriel reaction, okay? So that's another named reaction, okay? So for this reaction, okay, so yeah, yeah, that's kind of, yeah, for the primary amine, okay? So we have to, yeah, use a very special reagent called, yeah, yeah, forsamlite, okay? So this, okay, so structure shown here, okay? Forsamlite, okay? And so somehow, yeah, we protect kind of, yeah, this amine, okay, make kind of, yeah, the relative weak nucleophile, okay, and one kind of, yeah, overreaction, okay. And here it's kind of, yeah, what's going on, okay. So I also, because this kind of, yeah, relative kind of important reaction, okay, so I will also, yeah, write down here, okay. Right. So first, yeah, you get kind of, yeah, this forsamlite, okay. Yeah, NH, okay. And this actually kind of, yeah, you cannot directly use it for kind of, yeah, the yeah, nucleophile, okay. So you have to add into the base, okay. So deprotonate kind of this hydrogen, okay. So yeah, we add kind of, yeah, potassium hydroxide, okay. Right. N minus, okay, K plus, okay. Yeah, should be N minus here, okay. Right. Right. Someone asked question, does this group work because of electron? There's no oxygen here. Yeah, okay. That's right. Okay, so why this working? Okay, because the yeah, carbonyl group, okay, carbonyl group, okay, next kind of nitrogen, okay, so yeah, take electron away, okay, so make yeah, this nitrogen not so electron rich, okay, so that's why it's kind of, yeah, not good, yeah, nucleophile, okay, it's still a good nucleophile, but yeah, not as strong as kind of primary or secondary kind of amine, okay. All right, so that's, yeah, you get this one, okay, and then now, yeah, you can have kind of, yeah, substitution reaction. Normally it's just kind of here the yeah, SN2 reaction, okay. So that's, yeah, coming and kick out the group, okay. You generate some kind of here the yeah, intermediate, okay. So now we have kind of alkyl group, okay, attach kind of here nitrogen, okay. But yeah, that's not still kind of here the primary amine, okay. So you need to do some kind of, we call the deep protection, okay. So we need to remove this part, okay. This part is somehow like a protecting group, okay, protect amine, okay, won't like kind of, yeah, further react on, okay. So for deep protection, okay, so yeah, yeah, thorough way to do it, okay. The first one, okay, so yeah, you can use kind of, yeah, yeah, or normally potassium hydroxide, okay, and then under heat conditions, okay. Oh yeah, you can use, yeah, yeah, NH2, okay, that's a hydrazine, okay, NH2, okay. So either one is fine, okay, right, and then you can, yeah, give you back kind of your nitrogen, okay, and give kind of your primary amine, okay. Okay, so if you use kind of the yeah, potassium hydroxide, okay, so yeah, the yeah, another product should be kind of the yeah, dibenzoic acid, okay, diacid, okay. So if you NH2, okay, another product should be kind of something like this, okay. So NH, okay. So for the yeah, real, yeah, the yeah, exam quiz, okay. So that's, yeah, you don't need to draw this, yeah, byproduct, okay. So this one from here, okay. So you only need to kind of primary amine, that's enough, okay. Don't need to draw here, okay. But yeah, you do need to know the whole process, okay. So yeah, how do you, yeah, deprotonate kind of, yeah, forsamlite, how do you kind of, yeah, do substitution reaction, how do you kind of, yeah, do kind of, yeah, yeah, some kind of, yeah, deep protection, okay. All right, give you guys one example, okay. So this time I draw the two-step kind of combined together. Okay, so yeah, OH. And second one, okay, so this one kind of the butyl bromide. Okay, so that's the one way we show kind of a two-step okay together. Okay, after reactions done, okay. Yeah, put the butyl group on kind of the nitrogen K. So that's somehow kind of protect the nitrogen K. And then you just kind of do deprotection. Deprotection K. So yeah, here I use kind of the hydrazine K, NH2K, and then give you kind of butyl bromide, butyl the amine K. So yeah, pretty straightforward kind of reactions K. And then I did these reactions K, pretty nice K. So yeah, high yield K under the mild conditions K. So that's the first way kind of prepare kind of primary amine K. And the second way is kind of some another reaction K. So yeah, so it's not in our textbook, but yeah, the very useful Okay, so yeah, so you have to little bit write it down Okay, because that's not in our textbook Okay. So that's the azide substitution for the kind of reduction Okay. So pretty much kind of this the general reaction for here is kind of the third way okay, azide substitution okay, and for this reaction okay, so reaction okay, so just quickly draw kind of you guys what's going on okay, so you have some kind of alkyl whatever okay, and then react with kind of sodium azide okay, sodium azide kind of N3 okay, N3 kind of we learned in previous chapters okay, so that's the good nucleophile weak base okay, so yeah, pretty good for the SN2 reaction okay, and after reactions okay, so the simple substitution reactions okay, get N3 okay, so another kind of NA pick up CR okay. Right, okay, and then that's once it's done, okay, so you have to do one more step, okay, so called kind of a reduction, okay, to reduce the N3 into NH2, okay. So two conditions, okay. So one kind of use palladium kind of under use nitrogen, okay. So use some kind of do some nitrogen gas, okay. Or use kind of lithium aluminum hydride, okay. LiAlH4, okay. So that's very good in the reducing reagent, okay. And then once you compare either reagent, okay, so you get kind of primary amine, okay. Yeah. Actually, kind of this reaction I like it also a lot, okay. So reason for that kind of after you get kind of azide, okay, so either here, okay, so the palladium kind of catalyst is actually kind of just the heterogeneous kind of catalyst solid, okay. So you do filtration, you get kind of amine, okay. Hydrogen is gone, okay. And if you use kind of lithium aluminum hydride, okay, so this one can be dissolved in water, okay. And after the reaction, you do extraction, okay. So this one go to water, okay, aqueous phase, and then you amine will select kind of the organic phase, okay. Pretty neat reactions, okay. Actually, I'm doing this reaction kind of this 2 days, okay. So kind of good, okay, giving kind of nice yield, okay. And also the advantage kind of for this reaction, okay, once it's done, okay, so another byproduct is kind of the nitrogen gas, okay, it's gone, okay. Yeah. All right, give you kind of one example, actually kind of I'm doing kind of in my research lab, okay. Right, and the convert to kind of benzoamine, okay. Yeah, pretty straightforward reaction and a nice clean reaction, okay. All right, okay, so that's the amine preparation, okay. Keep in mind, okay, so directly direct alkylation okay, only can be used kind of prepare tertiary and then quaternary amine, okay. Gabriel reaction and also the azide reaction only can be used for kind of prepare the primary amine, okay. Someone maybe ask me, okay, so yeah, is there any way can prepare kind of the secondary amine, okay? So yeah, we haven't learned any way prepare the secondary amine, okay. The answer is there's at least 2 ways to prepare kind of secondary amine, okay. We will learn it kind of in the future the chapter, okay. All right, okay. And then the 7 reaction kind of the carbon-carbon bond formation, okay. So this is kind of note the specify kind of the what kind of the compound is made, okay. Not kind of alcohol, amine, or kind of alkyl halide case or whatever, okay. Just kind of story kind of carbon-carbon bond formation, okay. So for this the reaction case, so different from previous, okay. Previous kind of you build up kind of oxygen carbon or kind of nitrogen carbon bond, okay. So it's easy, okay, because heat your atom, okay. So one kind of electron one kind of nucleophile do substitution reaction, okay. But carbon carbon bond, okay. So both are carbon, okay. So that means kind of the one of the species has kind of as nucleophile, okay, and then has kind of strong electron the nuclear facility, okay. So benzene and CH2 kind of NH2, okay. So yeah. So primary amine, okay. Some people ask me kind of what structure and then the last one, okay. Yeah. All right. Okay, carbon formation, okay. So like I showed the kind of the on the screen, okay. So we have generally some the we call the kind of the carbon minus nucleophile, okay, called kind of the carbanium, okay. Carbanium, okay. Carbanium, okay. So pretty much just kind of the C minus, okay. And then you can do kind of the substitution reaction, okay. Let me see. All right, it's already kind of the 51, okay. So that means kind of the probably we stop here, okay. We continue the this chapter kind of the on Friday, okay. All right, so do you guys have any questions? Okay. Yeah, tomorrow discussion, okay. So we'll go through kind of the quiz 2, okay, and also do some practice, okay, for the chapter 10, okay. Help you guys prepare the exam 1, okay, probably next week, okay. Yeah, exam 1 probably next week, okay. So just be prepared, okay. So exam 1 much longer, okay. So at least 1 hour, okay, and I haven't decided which day, okay. So probably we also can vote for the date, okay, of the exam, okay. So for the exam, okay, so pretty much we still do it kind of online, okay. So I'm still thinking about it, okay. So probably in the middle of your semester, okay. So you guys can vote again, okay. So do you want to still do kind of smart work, kind of the online exam quiz, or kind of go back to kind of the respondents, okay? Respondents kind of monitor kind of you whole process by some kind of program, okay? So and then I can send out kind of paper-based kind of exam, okay? So or quiz, okay? So but the exam 1, okay, we still based on kind of the smart work, okay? What's the average of quiz 2? Right, so I'm still working on the quiz 2, okay, review the quiz 2, okay, and give you guys kind of partial credit, okay. Probably on Friday, okay, I can finish reviewing, okay. Yeah. Right. Yeah, looks like some people like the paper-based, okay. That's fine, okay. So probably after exam 1, okay. So we can vote it again, okay. So So do you want to go back to kind of paper-based? Just keep in mind paper-based kind of you have to use the software called kind of respondents, okay. So that's the pretty much take the video, okay. So when you take the paper-based exam, okay, or quiz, okay, and I never use it, okay, but the heard kind of the pretty interesting program, okay. Yeah. Can you show reaction that you said you are working on your lab again? Yeah. So that's this reaction. Okay, so we use the azide to convert kind of primary bromide to primary amine. Okay. I like to smart work online quiz. Okay, someone like a smart work online. Okay. We have to vote. Okay, so either we use kind of smart work or use kind of the respondents. Okay. So just kind of see which one kind of majority. Okay. So probably we do the kind of after the exam one. Okay. Yeah. Okay. Someone has techniques used for those responders. Okay. So in this case, if we decide kind of go back to the paper-based use responders. Okay. So you try to get kind of some kind of camera. Okay. Any option? Pretty much no. Okay, so we cannot have kind of both paper-based and also the smart work at the same time. Okay, so sometimes kind of the too much work for me, and also sometimes it may be unfair. Some people said kind of kind of the smart work kind of too easy. Okay, or kind of responders too easy. Okay, so either we do the responders or kind of we do smart work. Okay. Yeah, so we can vote again. Okay, so just see the to see majority which one's kind of favored. Okay. Yeah, we can. That's why I kind of feel the homework. Okay. So if you like, you can add more question homework. Okay. So so the homework help you kind of familiar with kind of smart work, how to draw the arrows, okay, how to kind of the here. Okay. Whatever. Okay. So but I don't know. Okay. So if you guys like more homework, then that's fine for me. Okay. Yeah. Sometimes if you start. Yeah, that's right. Okay. So make sure that your computer kind of working well before you start kind of the smart work quiz or exam. Okay. Close all other program. Okay, and then make sure your internet is working. Okay. So that's try to minimize kind of all the technical problem. Okay. Yeah. Yeah, the NMR IR instruction will be in the lab. Okay, so pretty much you follow instructions to be done. Okay, just no IR this week. Okay, because the instrument kind of down. Okay, so we only run carbon NMR. Okay, yeah. Just keep in mind. Okay, so even for the